In vector algebra, the scalar product, or dot product, is fascinating. It combines two vectors, a and b, to yield a scalar quantity. The formula is AB equals the magnitude of A times the magnitude of B times the cosine of the angle θ between them. This means if A and B are perpendicular, the dot product is 0, no work done. It's also commutative, so AB equals BA, and distributive, meaning AB plus C equals AB plus AC. This concept is crucial in physics, like calculating work done by a force over a distance. Understanding these properties can really elevate your grasp of vector relationships.
The cross product, or vector product, takes two vectors and produces a new vector that's perpendicular to both. Mathematically, it's expressed as A crossed with B equals the magnitude of A times the magnitude of B times the sine of the angle between them, multiplied by a unit vector n. This n points out of the plane formed by A and B, determined by the right-hand rule. Remember, the cross product isn't commutative. Swapping the vectors flips the direction of the result. If the vectors are parallel, the cross product is 0. This concept is crucial in physics, like calculating torque law with kete equals r crossed with F, or angular momentum with L equals r crossed with P. Even the magnetic force on a charged particle involves the cross product, expressed as F equals QV crossed with B. Understanding this opens up a whole new dimension in vector analysis.